Hello everyone. Today I wanted to show you a review of the three different methods we have for solving systems of equations and start to move towards deciding which one is best to use in a particular situation. So, as a reminder, we've got lots of different tools that we can use to solve a system of equations. The first thing we learned was simply to guess and check, but that's not really a really good option because there's tons of possibilities to look at, and so I'm going to cross that one off of our list here. The three big ones that we usually learn in Algebra 1 are graphing, or substitution, or elimination. And then there's one other strategy that I haven't taught you yet, but you might learn when you get to Algebra 2, and that is using a matrix. So that's a really cool option, but it's, again, not something we have quite yet, so I'm going to cross it off. So we're going to focus on these three today. As a reminder, for the graphing method, there were three steps. You had to graph each equation, and once you've graphed things, look and see where they intersect, and finally, take that pair of numbers and check it as our possible solution. So, here's an example. 3x plus y equals 4, and x plus y equals 6. This first equation, 3x plus y equals 4, I think is a good one to put into y equals form. So if I subtract 3x's from both sides, we get y equals negative 3x's plus 4. And then that 4 is our starting point, our y-intercept. And the negative 3 means we'll go down 3 and over 1. And so graph looks something kind of like this. And I would suggest again that you give this graph a label. I'm just going to call this A. I'm also going to switch colors. That makes it easy to tell what goes with which graph goes with which line, and so on. The other equation, being in a relatively clean, simple, standard form, x plus y equals 6, I think would be a good one to simply plot some points with. Easiest points I see are if you plug a 0 in for x, then that means y has to be 6. If you plug a 0 in for y, then that means x has to be 6. And so we've got a pair of points right there, 6, 0, and 0, 6. And if we connect those 2 points with a line, ideally with a straight line, but hey, whatever works, we can see that those two lines do intersect, and finding their intersection would be the point. It'd be somewhere around in here. It's really hard to tell because my graph is so messy, but I'm going to guess that that is a negative 1 for x, and maybe like a 7 or an 8 or a 9 or something like that. So let's try negative 1, 8 in a second, see if that works. So negative 1 for x and 8 for y does not work in that second equation. Negative 1 and 7 would work though. So let's backtrack a second, see if we make that a 7, if that works in both equations. So, and we've got negative 3 plus 7 does equal 4, and negative 1 plus 7 equals 6. And so there we go. Here's an example of where the graphing method worked, but it was a little sloppy. We definitely had to check our solution and tweak our solution a little bit before we got it to work. But hey, that's what happens sometimes with graphing. So now, substitution method was the first method we learned where it was paper and pencil, and we didn't have to worry about making any graphs, and so had lots of steps, but that's all right. First step was to get a variable alone, and then we substituted from one equation into the other, which gave us an equation that had just one variable in it. That's step 3. We tried to solve that. Once we figured out what one variable was, then we could take that and plug it into the other equation. That was step 4. And finally figure out what that one was equal to. It's step 5. So let's solve that same system. 3x plus y equals 4 again, and x plus y equals 6, but this time let's solve it with substitution. And so first goal would be to try to get one of the variables alone, and there's lots of good choices. I'm going to choose to try to get the first y in this first equation alone, because I already did that. I know how to do that. I'm going to subtract 3 x's from both sides, and that gives us y equals negative 3x's plus 4. And now we'll take that negative 3x's plus 4 and we will substitute it into the other equation. So this is step 2. Take this guy, plug it in over here for a y. So we'll write everything else in the equation. X plus, but instead of y, we'll put negative 3x's plus 4 equals 6. And now, step 3 in this is to try to solve this equation. And so, typically there's a distributing step. In this case, distributing a plus 1 to each of these things. So plus 1 times negative 3x is still negative 3x's. And plus 1 times positive 4 is still plus 4. We still have that x in front. Effectively, all we did right there was just drop the parentheses, but typically that step's more involved than that. And now we've got combining like terms we can do. These guys become a negative 2x's plus 4 equals 6. And we can subtract 4 from both sides, getting us negative 2x is equal to 2. And divide both sides by negative 2. And we've got x is equal to negative 1. So that's the end of step 3. Step 4 then is to take this newly found x value and plug it in for an x somewhere. Typically we go back to this thing that we had already circled earlier. It's an easy one to plug into. That gives us negative 3. Y equals negative 3 times negative 1 plus 4. And step 5, simply to calculate that. Negative 3 times negative 1 is a positive 3. And then plus 4, which is 7. So we get the same answer we got last time, because math is consistent. Doesn't matter which system or strategy we use to try to solve this. So, substitution method wasn't too bad in this case because it was fairly easy to get a variable alone. The last method that we learned was to use the elimination method. The elimination method has a bunch of steps as well. Another paper and pencil one, no graphs, which is kind of nice. So, first thing you do is try to get everything lined up. In our case, that's already happened for us, which is nice. Then we try to create an opposite. That's the most important one. Make sure there's an opposite. If there is, then you can move on to step 3, where you add the equations together and one of the variables will disappear. And then step 4 is a no-brainer, usually. Solve it, get that variable alone. And once we have one of the numbers, just like in the substitution method, steps 5 and 6 here, take that number and plug it in somewhere and see what we can figure out. So let's see how that applies to this problem. Over here, we've lined up the equations and we wrote them on top of each other, which is helpful for the elimination method. And step 1's already done for us because we have x's already, and y's, and equals, and numbers. So both of these were in standard form. It's nice. And so moving on to finding an opposite, and if we look at the x's, those aren't opposites, 3x's and 1x. If we add them together, they're not going to cancel out. If we look at the y's, a y and a y, if we add those together, they don't cancel out. So we got to create an opposite. The y's are probably closest because they're both the same amount, It's just that they're both positive. We want one of them to be negative. So let's make that happen. Let's take one of these equations. I'm going to just take the top equation here, and let's multiply it by a -1. That will turn everything into its opposite, including the y. So -1 times 3x becomes -3x's. And -1 times y is that negative y that we wanted as an opposite. Don't forget to multiply everything. So -1 times 4 is -4. And I'm going to just cross this out so I don't get distracted by it. Now I've got two equations still lined up, x's, y's equals numbers, but I've got opposites there, the y's in the middle. So let's add these equations together. An x and a -3x adds up to a -2x's. A y and a -y adds up to nothing, and so I'm not going to write anything. And a 6 and a -4 adds up to a +2. And step 4 is pretty simple. Let's divide both sides by -2 and get one of our variables. X equals -1. Like in the substitution method, once we have one of our letters, we should plug this in somewhere. We could go back to our original equation and plug it in there. We could plug it into this equation. We could plug it into this equation. It doesn't really matter. I'm going to pick that one in the middle because I think that's the simplest of all of them. So I'm going to take this x and plug it in here for this x. That gives me -1 plus y equals 6. And simply adding 1 to both sides gives us our y value of 7. And once again, we see same answer as before. Again, math is consistent. Doesn't matter which strategy we use, they all work. So, one nice thing about this particular problem that made it kind of easy to use the elimination method on is that everything was already lined up. So, truthfully, this system was a good one to use with any of them. It wasn't super hard to graph. It was pretty easy to get a letter alone for substitution. And of course, as we saw here, everything's lined up, which is a good first step for elimination. So, in this table, I've shown some of the advantages, and I didn't want to use the word disadvantages, but the advantages and the needs of each of the different methods that kind of help us to decide whether or not we should use one strategy over another. So, in the graphing method, some of its advantages, it's a visual method. A lot of people like seeing things, and so there's definitely advantages to that. I think it's one of the easier ones to explain. It's graph the two lines, see where they intersect. It's not simple. It's not very complicated. It's actually very easy to do with a calculator, specifically with the super great Desmos calculator, where you can simply type the equations in. You don't even have to manipulate them at all. And so if you're allowed to use a calculator, graphing technique, really nice. So, but it does come with a set of needs. To do it really well, you need graph paper. If you don't have graph paper and the equations have even just a little bit of challenge to them, it's going to be hard to find the intersection. Or you need a graphing calculator or permission to use a tool as powerful as Desmos or something like that. And if you are going to do it by hand, it'd be really nice if your equations were kind of nice. If they were both in y equals form, or if they were in really easy standard form, where you could find intercepts without having to deal with nasty fractions or something like that. Not every equation comes that way. Some systems just aren't going to be easy to graph. And so, anyway, graphing has its advantages, has some disadvantages as well. So, substitution method, one of the reasons substitution method is good is it allows you to find an exact answer to a problem that is messy to graph. For instance, if the intersection happened to fall on some ugly decimal places or fractions or something like that, the substitution method would still allow you to figure out what the exact answer is, so that's good. Another advantage to the substitution method is it's a really routine process. If you remember that lesson, every problem looked the exact same. It was consistent, relatively easy to do. I mean, once you get it, there's no surprises. So that can be an advantage as well. One of the needs for substitution is you need to be able to get a variable alone. And so if you can't get a variable alone, a substitution method actually becomes pretty challenging. So the third technique we learned was the elimination method. And one of the advantages is just like substitution. You can get an exact answer even if it's a messy graph. Another really important advantage for the elimination method is it has the possibility to be quite quick, but not always. It's quick if you've got equations that are shaped the same, x is y is equals numbers, x is y is equals numbers, and also if you've got a nice juicy opposite in there that you could add things together and stuff cancels out right away. But if there isn't an opposite, then you got to go creating one, and that can slow things up and take a lot of time. So anyway, those are the different strategies we've learned, and some things to look for if we wanted to use one versus the other. And so let's look at a handful of equations and just say, what would we try to solve it with? So in these four, which method would you choose to solve for each of them? I'd encourage you to pause a second and look at each one and write down which method you think might be a good choice to use. And then when you're ready, hit play again, and we can share which options we think are wisest. So in this first example, the thing that I see right away is I've got a letter already alone. Y equals x plus 3. So the other equation is a nice one to try to find intercepts with, and so I would recommend for this one either using the graphing method, or if you don't have graph paper available or you can't use a calculator, then I would suggest using the substitution method. Since you already have that y equals, it'd be pretty quick to simply plug it into the other equation and see where we go from there. So, good thing I can spell, huh? Substitution. So, in this equation over here, with the a's and the b's, if this equation doesn't scream elimination method at you, then I don't think I've done a pretty good job of teaching. Look at that opposite in the middle. This 5b, negative 5b, everything's lined up. I would immediately add these equations together and see what happens. So definitely an elimination one. It would be a pain to graph, and I don't see a good strategy to get any of those letters alone without inducing some fractions, and so eliminate that one. Down in the bottom here, this P's and Q's problem, I would suggest, again, either graphing or substitution. The fact that we've got both of these in y equals form, I understand it's p equals, but they're both in y equals form, would make for a relatively easy graph, or it's really easy to substitute. Simply put the 300q into the other equation down here, and you can solve that one. I'm going to write this one down as a graphing problem, though, and the reason why is because I recognize these P's and Q's. That's for profit and the quantity of things that we sell. This would be a good one to graph. It comes from an economics situation, and a lot of reasons. There's also added benefit for having a graph besides simply solving the problem for economics problems, and so this would definitely be really a good one to make a graph of. Probably on a computer or calculator. Alright, that leaves this last guy over here. 2/3 x, yuck. Well, I suppose I could see an argument for trying to get this y alone, and making a substitution. But with everything already lined up, and I really want to multiply this top equation by maybe a 3 to get rid of the 2/3. Since I'm thinking about multiplying the top equation by 3 anyways, I think I'm probably going to end up solving this one with elimination. And I'll see if I can also do a little bit of thinking to figure out what to multiply the bottom one to create an opposite by. So I would recommend elimination, although I could see substitution. I probably wouldn't try to graph it, though. It doesn't look easy to graph at all. So anyway, I would encourage you to try to solve each of these and see how they turned out for you. I'd love to see how it works. If you can leave a comment down in the comment section below if you want, or just have a wonderful day.